In this video, we're going to talk about how to calculate the molar mass quick and easy. So before we begin calculating the molar mass, we need to go through some basics. So the periodic table has the list of all the elements known to man. So the way it's set up is that you have, for example, you have carbon right here. And this number right here is the atomic number. So the atomic number for carbon is 6. The value that we're interested in when calculating molar mass is the value that is below, which is the average atomic mass for that atom or element. So for carbon, the average is 12.01 grams per mole. Grams per mole is the standard unit when talking about molar mass. It basically just means that for 1 mole of carbon, it weighs 12.01 grams on average. The second example I have right here is for boron. So boron has an atomic number of 5 and an average atomic mass of 10.81. Therefore, 1 mole of boron is going to equal 10.81 grams per mole. So now that we know how the periodic table works and how to find the average atomic mass, we're going to go through some practice problems. So for the first one, sodium bromide, we have, the way I like to begin these problems is to go ahead and make a list of all the elements or atoms that are in your molecule. So right now we have sodium and bromine. Sodium has an average of 22.99 grams per mole. And bromine has an average of 79.90 grams per mole. Now you just add them all up. So when you add all these up, you're going to equal 102.89 grams per mole. So 1 molecule of sodium bromide is going to equal 102.89 grams per mole. The next one we have is calcium hydroxide. So like the previous one, we're going to go ahead and list out our atoms. So we have calcium, oxygen, and hydrogen. Now for calcium, we have 1. Oxygen, we have 2 because of the 2 outside of the parentheses. And same thing for hydrogen, we're going to have 2 of those. So for oxygen, that is 16.00 grams per mole. And for hydrogen, that's 1.01 grams per mole. Calcium is 40.07 grams per mole. Now the periodic table actually has calcium as 40.078. Oxygen is going to be 15.9994, and hydrogen is 1.0079. But for simplicity's sakes, I just round it to the nearest 2 decimal places. Some people even round it to like the nearest whole number. So for like hydrogen, they would just say it's 1 gram per mole. But to be a little bit more precise, I'm going to keep the 2 decimal places. So once we multiply these out, we have 40.07, 32, and 2.02. The last step is just to add all these up, and you'll get a number of 74.09 grams per mole for calcium hydroxide. The next example we have is sodium phosphate. So for sodium, like we did before, we'll go ahead and list them out again. And after a while, after a lot more practice, you won't have to necessarily list these out every time. You can just use your calculator and calculate it all together. But to make it easy and so that you can visualize it, I'm going to go ahead and keep listing them out. So for sodium, we have 3. Potassium, we have 4. Or phosphorus, not potassium, sorry. And then oxygen, we have, phosphorus, we have 1. Oxygen, we have 4. And for sodium, like we said before, it is 22.99. Phosphorus is 30.97, and oxygen again is 16.00. So for sodium, we go ahead and, or for this molecule, we'll go ahead and multiply these out. So for phosphorus, we have 30.97. For oxygen, we have 64. And for sodium, we have 68.97. I'll go ahead and add all these together, and we will have a total molar mass of 163.94. The next problem we are practicing is C6H12O6, also known as glucose. So previously we listed them out. For this one, I'm going to go ahead and just write the number that we have. So we have 6 carbons times 12.01. Hydrogen, we have 12, 1.01. And oxygen, we have 6 times 16.00. So for carbon, we have 72.06. I'll go ahead and just write them out over here so we don't get confused. Hydrogen, we have 12.12. And oxygen is 96.00. We add all these up, and we're going to get around 180.18 grams per mole. The last one to practice for this video is this big one right here. I don't actually know the real name of it. I'm pretty sure it's some sort of acetate, maybe zinc 2 acetate. But however, for this one, we're going to go ahead and list them out just because there's so many different atoms and elements. So we have zinc, carbon, hydrogen, and oxygen. So for zinc, we only have 1. For carbon, we have 2 times 2, so we have 4. Hydrogen, we have 3. 3 times 2 will give us 6. And then oxygen is the 2 times 2, which would be 4. Hydrogen again has 1.01 grams per mole. Oxygen 16.00. Carbon is 12.01. And zinc is 65.39. So we'll go ahead and multiply these out. 12.01 times 4, 48.04. And 16 times 4, give it 64. And you just add all these up. When this will give us a total molar mass of around 183.49 grams per mole. So as you can see, out of all these, it looks like this last one has the highest molar mass, which 183 still isn't necessarily super big or super large, but compared to like something like H2O, which has a molar mass of about 18, this is a pretty large molecule. That's all I have for this video. If you want some more practice on molar mass, I can for sure make another video covering some more examples. I can also make a video showing how to calculate the molar mass using a molecule that's written out. For example, like just sodium bromide. They don't give you the actual the actual the actual molecule numbers and everything like that. But yeah, so that's it for this video. Thank you for watching. Tune in, make sure you like and subscribe if this helped you, and I'll see you in the next one. Peace.